Imagine taking a single breath, plunging nearly 2 miles into pitch-black ocean depths, and holding that breath for almost 4 hours, while surviving crushing water pressures that would instantly destroy a steel submarine. Now imagine doing all of that while being a warm-blooded, air-breathing mammal, just like you and me. Welcome to the extraordinary world of marine mammals. From the blue whale, the largest creature ever known to have lived on Earth, to the sea otter, which stays warm using the densest fur in the entire animal kingdom. Marine mammals have engineered some of the most unbelievable evolutionary survival tricks on the planet. Today, we're diving into the essential biology, extreme adaptations, and surprising behaviors of marine mammals. Make sure to hit that like button and subscribe to the channel so you never miss our deep dives into fascinating scientific facts. To understand marine mammals, we first have to answer a fundamental question. What actually makes an ocean creature a mammal? Despite living in saltwater, marine mammals share the exact same core biological traits as land mammals. They breathe air through lungs, are warm-blooded, endothermic, give birth to live young, produce milk via mammary glands to nurse their offspring. But how did land mammals end up living in the ocean? The fossil record shows that around 50 million years ago, during the Eocene epoch, four-legged terrestrial ancestors, such as the hoofed mammal Pakicetus, began hunting along shallow riverbanks. Over millions of years of natural selection, their nostrils migrated to the top of the skull to form blowholes. Their front limbs evolved into streamlined flippers, their hind limbs regressed, and their bodies developed powerful tail flukes. Scientists classify living marine mammals into 4 distinct taxonomic groups. 1. Cetaceans, whales, dolphins, and porpoises. Fully aquatic mammals divided into baleen whales, Mysticedae, which filter feed on krill and small fish using keratin plates, and toothed whales, Odontoceti, which hunt individual prey using teeth and specialized echolocation. 2. Pinnipeds, seals, sea lions, and walruses. Fin-footed semi-aquatic carnivores. True seals lack external ear flaps and haul out by wiggling on their bellies, whereas sea lions have visible ears and can rotate their hind flippers forward to walk on land. 3. Sirenians, manatees, and dugongs. The only completely herbivorous marine mammals, inhabiting warm, shallow coastal waters and rivers where they graze on aquatic vegetation. 4. Marine carnivores, sea otters, and polar bears. Sea otters spend almost their entire lives at sea in kelp beds, while polar bears are classified as marine mammals because they rely almost entirely on sea ice ecosystems and marine prey like ice seals to survive. Living in the ocean presents brutal physical challenges for an air-breathing animal. Heat drains into cold water 25 times faster than air. Atmospheric pressure increases by 1 atmosphere every 33 feet of depth, and oxygen is completely unavailable underwater. So how do marine mammals survive? Let's look at heat regulation first. To stay warm in freezing polar oceans, whales, seals, and walruses possess a thick layer of specialized fatty tissue beneath their skin called blubber. Blubber acts as thermal insulation and an energy reserve. Furthermore, their circulatory systems utilize countercurrent heat exchange. Warm arterial blood flowing from the core transfers its heat directly to cold venous blood returning from flippers and flukes, preventing heat loss to the cold ocean. Sea otters, however, lack blubber entirely. Instead, they survive using sheer fur density, packing between 850,000 and 1 million hairs per square inch. This double-layered coat traps a thin layer of air right against their skin, preventing cold ocean water from ever making direct contact with their body. When it comes to diving, deep-diving species like the Cuvier's beaked whale hold world records. Scientists have tracked one diving to a depth of 2,992 meters, nearly 9,800 feet, and staying underwater for 3 hours and 42 minutes. How don't their lungs collapse or suffer from the bends? Unlike human divers, deep-diving marine mammals do not rely on storing air in their lungs during dives. Before a deep dive, they exhale a allowing their flexible rib cages and lungs to safely collapse under pressure, forcing remaining air into non-absorptive upper airways. They store up to 90% of their oxygen inside their blood and muscle tissue, using exceptionally high concentrations of oxygen-binding proteins called hemoglobin and myoglobin. During the dive, their heart rate dramatically drops, a physiological response known as the mammalian dive reflex, redirecting oxygenated blood exclusively to the brain and heart.
Beyond physical physiology, marine mammals possess some of the most sophisticated neurological and social structures in the entire animal kingdom. In the pitch-black depths, where sunlight cannot penetrate, toothed whales rely on echolocation to navigate and hunt. A specialized organ in their forehead, filled with fatty acoustic tissue called the melon, focuses high-frequency sound clicks generated in their nasal passages. These sound waves bounce off target objects in the water column, returning as echoes that pass through fatty channels in the lower jaw directly to the inner ear. This creates a detailed 3D acoustic image of their surroundings, accurate enough to distinguish prey species in total darkness. Brain complexity in marine mammals is equally staggering. The sperm whale possesses the largest brain of any animal in Earth's history, weighing roughly 9 kilograms, 20 pounds, over 5 times the weight of a human brain. In species like the Orca, killer whale, brain regions involved in processing emotion and social memory, such as the paralimbic system, are proportionally massive and highly folded. This brain power translates into distinct animal cultures. Different pods of orcas pass down specialized hunting strategies and vocal dialects from grandmothers to mothers to calves across generations. For example, Norwegian orcas use carousel feeding, slapping fish with tail flukes to stun herring, while Antarctic orcas work in coordinated teams to create wave washes that knock seals off icebergs. These learned traditions are culturally transmitted, meaning different populations do not interbreed or share dialects, even when sharing the same ocean waters. Humpback whales demonstrate cultural evolution through complex song patterns. Male humpbacks in a population sing the same intricate, structured song during breeding seasons, continuously modifying themes over time. When a new variation emerges, it spreads across entire ocean basins, a phenomenon marine biologists explicitly define as cultural revolution. As we look to the future of our oceans, these extraordinary creatures leave us with a fascinating mystery to ponder. Given that marine mammals successfully evolved from four-legged land animals into deep-sea navigators over 50 million years, how will their complex social structures and adaptive behaviors respond as rapid human-driven changes alter the ocean chemistry and temperature they depend on? Let us know your thoughts in the comments below.